Hi everyone, my name is Leila Abdelrahman, and today is the first of many lessons on Intro to Python Programming. So I thought I had a lot of free time, and I like making these courses on my website, but then I had the idea of also making these short video tutorials on programming, and that way, I can explain the thought process behind the code snippets and everything, and you can gain more clarity on programming techniques and stuff like that. So I thought, why not make a video series and post them on YouTube? So that's what I'm going to do today, and hopefully you enjoy. So this lesson is about data types and functions. So there are a lot of different types of data structures and data types in Python. We're first going to go over what primitive data structures are. So they're typically four. Well, we're going to cover four data structures, primitive data structures, data types today. The first is a string. So strings are basically anything that's encapsulated in this quote. It's like a quote. And basically what they are is they're like statements, words, sentences. They can be as short as an empty string with nothing in it, just two quotes and nothing in them. And they can be infinitely long. So, yeah. Strings are kind of ways of storing text is how I would think about it. Then you have floats. So floats are just decimal numbers. So they can be negative, positive. They have to have a decimal point in them to be considered a float. So something like 1.5 or pi, for example, 3.1549, right? That's also a float number. Integers are discrete numbers, meaning that they are they don't have decimals in between them. It's only like 1, 2, or -1, -5, -15, right? Those are all integers. And then finally we have booleans. So booleans are true or false statements. So a boolean statement could be I'm a woman, right? And that would be equivalent to true. Like that could be an example of a boolean statement. So yeah, then we have things, the more complex data structures. So there's three of them. There's lists, there's sets, and there's dictionaries. So we're going to go over all three of these. So lists are basically, it's kind of what you think they are. They're lists of items. The thing about lists is that they can have repeating items in them. So as an example, let's think about a grocery list, right? So in a grocery list, you have like eggs, butter, milk, maybe hand sanitizer, and it's currently coronavirus season. So, oh, I'm gonna get another hand sanitizer. So yeah, you can have repeating units in a list, right? Sets, on the other hand, can only have unique values, meaning that I can't have repeating elements in a set. So you see over here how we have like repeating, here we repeat the number 3 in the list, but in the set we only can have number 3 once, right? Dictionaries are similar to hash maps, and they're a way to map keys to values. So in this case, the keys are always going to be to the left of the colon, and then the values are always going to be to the right of the colon over here. So yeah. They're a way basically to map information to something that's associated with it. The thing about dictionaries is that the set of keys has to be unique, meaning that only one key can map to something. You can't have repeating keys in a dictionary. So if I have a contact list, I can only have unique names. I can't repeat the name, for example. So if I try to map the first name in my contact list to a number, I can't have repeating names. I can't have repeating Miguel's. I can't have repeating Sarah's, right? It can only be one name. That's dictionaries. Right, and so in a list, the way we index things is like how we actually extract information from a list is that we have to use brackets over here to kind of reference the index. So the index tells us the position of an element in a list or a set or a dictionary. So an index. So in Python and in most other languages in programming. the indexes are always base 0, meaning that when you actually start numbering things, enumerating things in positions, we always start at 0 and then we go on. So if I have a list that has 9 elements, I'm going to have my highest index would be 8, right? Because I start at 0 and then I go up to 8. So if you count 0, 1, 2, 3, 4, 5, 6, 7, 8, I counted 9 times, but because I started at 0, my highest index would be 8, even though I have 9 things on my list. Yeah. So now printing, right? So printing is fun because you get to see well, before you cover printing, I just want to cover like a variable assignment. So you can assign variables by just having the name of the variable on the left with an equal sign, and then your expression or your whatever value that you're going to be assigning to that variable will be in on the right hand side. So here I have, let's say v for variable this is equivalent to a string, right? Then pi is going to be a float, right? Then number of books would be an integer, and then I am female would be true, and that's a boolean. So if I actually like print this out and I have these print statements, right? You can easily print to the console just by having print with the parentheses and then whatever you want to print inside. The thing about when you're trying to concatenate strings in this case with non-string values, you have to put a comma. Usually in other languages you can put a plus, but like in Python you have to put a comma when you're combining non-string and string values in a print statement. So here, if we like see all this, this is the output that we get, right? Number of books was 50, right? The value of pi is equal to pi, and then it prints it as 3.14, right? I am female it gets the value of I am female, which we assigned as a boolean right over here. It returns true, right? So here, again, this is like more complex, just like printing complex data structures. So again, here is an example of a grocery list. So a grocery list, right, you can have repeating things in it. So like milk over here, you see is repeated twice. In a set, you can only have unique values, so again, you don't see anything repeating. And then dictionaries, again, they have keys, which are always on the left of the colon, and then values, which are on the right. And then again, I'm just trying to print everything out over here. And then this is the output, right? You see my grocery list over here. My favorite color is my favorite color over here. I have a set of my favorite colors, and then you can print the dictionary and you'll get this as your output. Cool. Now let's go over operators. So operators are just like mathematical operators, right? You have like addition, subtraction. You have your standard ones, but in coding you have some unique ones as well. And well, before that, there's 3 types of operators. There's arithmetic, which are again, like I said, like mathematical like operators. Logical operators are things that kind of like they tell us how to combine things, so like and or statements. And then relational operators compare things. So compare if something is equal to something else, greater than, less than, etc. So in arithmetic operators, again, the ones that you have your standard addition, subtraction, multiplication, whatever. You have 2 over here that I want to cover, and more specifically, you have the modulus operator and the floor division. So modulus basically just gives you the remainder. So 7, and it's specified by this percent sign. So 7 mod 6, the output of that would be equal to 1, right? And then you also have floor division. What floor division does is it basically rounds whatever your output is to the nearest. It rounds it down to the nearest integer. So you can think about floor as like being the lowest, right, kind of thing. So here, for example, 9 floored by 4 would be equal to 2, right? Because in reality, 9 divided by 4 is what is that? 9 divided by 4 is like 4.5. No, 2.5, right? Yeah, and then when you floor it, you round down, right? So it would be equal to 2. Relational operators, again, you have if you've taken math classes, which I hope you have, you should be kind of familiar to you. You have equals, does not equal, and already have like a not in Python. You have like this this like expression here, this not equal, greater than, less than or equal to, or greater than or equal to, right? So it's just helpful for comparing. You can compare strings this way, you can, and I'll just do it alphabetically. You can compare floats, you can compare integers, and then with booleans you can use these statements. You can't use the other ones because obviously booleans, there is no such thing as a boolean being greater than another boolean. That doesn't work. Alright, logical operators are a way for us to combine things, so you can have or, and not. So or basically means like if this is true or this is true. So it's just one of the conditions has to be satisfied in order for the entire statement to be true. And means that both this and this have to be true, or both this and that have to be true. So basically it says that both things in your conditional statement have to be true in order for it to return true, and then not is basically just the opposite of whatever you're stating. So if I am saying I am female, remember over here we had I am female, but as being a boolean, but then I said not I am female, it would actually return false, right? Okay. Right, so here we're going to go over if statements, and if statements are a way to basically execute code if a conditional statement is satisfied. So here, our conditional is this boolean, I am female, right? So you're saying if I am a female, meaning it'll only execute the code if the conditional is true, right? So I'm a female is our boolean, it's our conditional. If I'm a female, so if true, right, because we assigned it as true, print I'm a female. So it'll actually print I'm a female because it's true. Now here is another one. This is more complex. So this is including our logical operator and. Again, when we said that, we have to say that both of these, I am a female and this conditional, have to be satisfied and be true in order for it to print, right? So here, I'm a female is true, so this part is true. And then I is equal to -1. Well, is -1 greater than 0? No, that's false. So this won't, this entire thing will be false, right? And then we won't print I'm a female. Okay, how about this one? So here it's an or statement, right? So here, remember in or statements, unlike and statements, in or statements, at least one of them has to be satisfied in order for our statement to return true. So here again, I'm a female is true, so at least one of them has been satisfied, even though -1, I, is less than 0, so this is still false. In total, because we have our or logical operator, we will return true in our conditional, and we will print I'm a female. Great, now let's go over for and while loops. So for loops are just ways of iterating over a range of numbers. So here, basically what this does is when we say for I in range 0, 5, that basically means it's going to repeat something 5 times, right? A thing about the range over here in our for loop is that the first number is the lowest value and it's always inclusive, meaning we include it in our range. The last number in our range is always exclusive, meaning that we'll actually stop when I is 4, not when I is 5, right? So we'll end when I equals 4. Yeah, and then you can do something. And then with while loops, basically, again, you have a conditional. And this basically says that while this conditional is true, right, do something, then increment. If you don't include an incrementation for your conditional, you're going to get an infinite while loop, and your program will run on forever because it's always going to be true. Unless you do something to change it, in this case we're iterating, we're changing I at the end of our while loop to then increment, and then eventually I will be greater than 5, and then that will return false, and then he'll break out of the while loop. So the goal of this is to release a video maybe once or twice a week. Thank you so much for listening and learning, and yeah, just put any of your questions down in the comments below, yeah, happy coding. Thank you so much.